This is about our environment. As concerns about the environment rise and we begin to really feel the impact of global warming, AI presents itself as an unexpected but promising tool in the fight against climate change. Hello, everyone. Welcome to one more episode of Unlocking the AI Advantage podcast. This is your host, Ramesh Danta. Today is an interesting topic that we're going to go deep into. So the topic today is AI in environmental conservation and resource optimization. So until a couple of years ago, the topic of a climate change, global warming, and the environmental conservation was all over. Even now it is all over, whether it's a UN, whether it's a World Economic Forum. So there's a lot of discussion about these topics. But it seemed like we didn't have a solution until AI showed up, started ramping up. So today we're going to go deep into how artificial intelligence can actually start helping us tackle this serious problem. AI within sustainability is now charting new pathways to monitor, analyze, and address environmental challenges. Forecasts suggest that by 2027, in literally 3 to 4 years, AI-driven environmental solutions will significantly impact carbon footprint, waste management, and conservation efforts on a global scale. To get more into this, we have two expert panelists who will help us dive deeper, Dr. Bram Rhodes and David Carter. So let's dive in.
Hi, folks. Bram Rhodes here, based on the East Coast in the U.S. I'm one of the founders and general partners at Malika Ventures. We're an early stage climate tech fund investing at pre-seed and seed, and we invest through what we call a climate justice lens. So that means we place a lot of emphasis on who's going to benefit from the innovation and less so on who built it. We invest broadly across the climate space. So the five main drivers of climate change: the built environment, transportation, energy, food and agriculture, and manufacturing. And then we have a sixth category that we call sustain, which is basically perfect for this talk today, which is how do we leverage data, AI, and technology to better understand the environment and create more sustainable solutions.
Thank you very much. So David, go ahead, please.
Hi guys, Dave Carter, CEO and one of the founders of Deep Planet. We're building the world's ultimate climate platform, helping farmers and agriculture adapt to and reverse the effects of climate change. We use satellite imagery, weather data, ground data, and machine learning models to really help farmers adapt to and reverse the effect of climate change. And we started with the wine industry and have now expanded to other crops such as cattle, ranches, native species detection, disease monitoring, and sustainable supply chains. So yeah, excited to be on the panel and give some feedback on what we're doing.
So David, I think apart from the work that you do, so you're close to the wine industry. So with that one statement, you'll be close to a lot of us who really love wine.
Exactly.
So we'll be in touch with you after the talk. Okay. All right.
No problem.
So with that, so let's get deep into it. So the very first question, let me start with you, David. Environmental conservation. I know we bandied that word around, but it's too broad. So can we talk about specific areas, where AI actually could be applied towards environmental conservation?
For sure. So lot of areas could be applied. One of the things about the environment, it's right across the world, and it's at scale. So really monitoring of nature at scale, whether that's what's changed or picking up problems as they occur early than they would, because we as humans we can't be everywhere at any time. So really using AI and then the satellite imagery, using weather data to really see impacts of what's happening in the environment is one area that I think is obvious and a huge one. On top of that, obviously, climate modeling, something else we get asked to do a lot is saying where have we come from in terms of temperatures and climate, where are we today, and where will we be in 5, 10, 20 years as people start planning out planning out what's happening and changing with the climate. So running different scenarios and running different models and seeing how it would impact people's businesses and also the environment, whether that's public or privately owned land.
Okay, so great. So Bram, I know you're looking across the spectrum because of your investments, multiple startups and all this stuff. So where are you seeing AI is beginning to or has already made some impact in the environmental conservation areas?
Well, I guess speaking to David's company and his experience, so precision agriculture is definitely one of the spaces that AI is, already in use, already making an impact, and already, and will just continue to grow. That's everything from planting to also kind of weed and pest management and so on and so forth. You've got all kinds of different systems and solutions out there. The other spaces that you're starting to see some movement are kind of on the large scale issues: environmental monitoring, wildfire monitoring, bringing in in Earth orbital and near Earth monitoring systems, and basically leveraging that data to do more accurate weather predictions and forecasts, which is still despite all of our advances a challenge. And then on the other end of the spectrum, you've got AI, computer vision and AI solutions for sorting waste, or for creating more carbon friendly or carbon negative concrete and other approaches in AI in manufacturing for cleaner and less polluting outcomes. It's AI. We all know it's here. It's here to stay, and it has broad applications. And climate and the environment covers the entire economy, and AI is going to cover the entire. It's going to have applications and usefulness across the economy. So it's going to be the same in AI. That the applications are endless.
So Bram, actually following up on that comment. So until a few years ago, right, people said, hey, it's a doomsday. It's saying that, hey, there's no way that we can make progress. And suddenly we see this promising tool, AI, which seems to really give lots of opportunity, lots of tools for lots of countries, lots of agencies, maybe beginning to make some impact towards whether it's a global warming, whatever, right? So what aspects of AI, what is it about AI that is making us think that, hey, maybe, we can make an impact?
Well, without kind of giving into the hype, one of the challenges is that we think, oh, AI, it's this super smart system. It will help us solve all these problems. I mean,
yeah,
that's, there's a bit of, kind of, again, there's a bit of hype to that. AI, one of the things to remember is that AI has been around for decades. It has shown incredible usefulness across any number of applications that haven't necessarily captured the broader public's attention. But now that we've got things like ChatGPT and large language models in general, et cetera, and people are like, oh, this is great. It's important to remember that there are some very fundamental, basic machine learning approaches that we don't normally classify as AI that have been providing very credible solutions across a wide variety of applications. But in the world of, in general, the technical advances in AI are accelerating a bit. And then as we come up with more and cheaper ways to collect data, which is really the driver, it's, AI without data is meaningless. So, coming up with cheaper and more effective ways to collect the data then just allows us to continue to develop AI solutions that
so what you're saying is the access to data, having the data sets, ability to collect all that stuff is is the one that's exciting all of us. So David, you are the man on the ground. And so you're working with lots of data. So, and of course, you guys wanted to go and start a company because you see an opportunity here. So what about AI from your practical perspective is helping you, saying that, hey, we can make an impact?
So the one a lot of things that have come about. One thing that changed, and it leads on from Bram's question for us, is we rely heavily on satellite imagery and a wide spectrum of data. Those satellites have now been launched. It's kind of 2016, 2017 that we primarily use, and it's been a regular heartbeat of data on every single piece of land in the world every 3 to 5 days since 2017. And so with that, we basically have a heartbeat of data that as a starting point across a wide light spectrum band that we can compare our information with to then build our machine learning and data sets as a foundational models. So as an example, we can then say we've actually collected, we have some in some areas, whether it's disease monitoring, whether it's sugar or harvest logistics for grapes, whether it's soil organic carbon or soil nutrients. We've taken hundreds of thousands and in some cases millions of samples and taught our AI and matched to that historical data set of satellite imagery to allow us to, and weather data and other components that we build into our models, that has really enabled us to make these huge leaps forward in what we're able to monitor and measure and predict. So it's that historical data set has really been uplifted. In addition, if it's specifically talk about Earth observation as well, I think there's been more satellites launched in the last 5 years than there were in the last 50. And in the next 5 years, there'll be 10 times as many launched as there were that exist today. So just the huge, I mean, just in that's one small area of AI, but you see that there's just an explosion of the amount of data. There's too much for a human to even look at. And now it's enabling AI to really hone and fine tune and get better and monitor better information.
Fantastic. So that's great. So again, to the audience, so now that we have laid the foundation of where the discussion is going to go, so you could even continue in the same way, or you could say, hey, no, I have this question, so please address this. So go ahead and put in your questions now to have a meaningful discussion about things that are of interest to you. So with that, David, so you talked about satellite imagery, how the data from that is helping. And so can you actually get into some specific examples of where and how you've used AI for in it's wine industry or some precision agriculture area that you would like to talk about?
Of course, and to me they're really exciting. So I'll try and keep it as concise and short as possible. But there's 4 main areas for us. So first one, regional monitoring. So really exciting. One of the first things we did back in 2018 was actually develop the ability to detect grapes or to detect vineyards. And that's a foundation, again, a foundational layer. But a lot of areas they don't actually have any way of understanding where their vineyards are, and they can't really prepare to service them, or they can't actually look at biosecurity risks, so diseases, or if it's flood or hail, or really understand what's happening. So for many regions of the world, places like Oregon, Riverland in Oregon in the US, Riverland in Australia, we've monitored places in France and New York State. We monitor the whole state to detect where all the vineyards are. So that's where we've taken the ability of detecting. Creating algorithm to detect what a vineyard looks like and actually show what the current plantings and what the changes are over time. We obviously, like I mentioned, we can go back 5 years and we can monitor this on a yearly basis. A second area is around the diseases. So there's 12 major pests and diseases that affect grapes. And because of climate change or changes in weather, the diseases are affecting areas that have never had these problems before. So we've actually been able to pick up the digital signature of each of the kind of 12 major pests and diseases that affect grapes and vineyards, and they do affect other crops, but that's where we started as well. And it allows us to either monitor a spread of a critical disease like phylloxera, which is the worst kind of disease you can get in vineyards that don't have original rootstock, through to kind of more common ones like botrytis or others which you can treat instead of kind of having wholesale rip out of them. So detecting those symptoms and using everything from non-visual light spectrum changes to just picking up the symptoms, reg blotch, or other ones quite easy. And then the last one that's second last one that's really key in understanding how we apply some of the AI to techniques is on maturity and harvest. So typically today, to go determine when you harvest a grape, the winemaker goes out there and tastes the grape and says, oh, it's about ready. Might test it manually for squeeze the juice and say how much sugar is in there. But we can actually do this remotely now. We've actually been able to work out how we've taken hundreds of thousands of samples from across the world, from the time of when the grapes are called raisin, they change color, through to when they're actually harvested, and it actually helps them understand where and when to harvest, guarantee a higher quality of grape and higher quality of wine, and enable them to really pick it at the time when they're able to do it. And this, we create a map and we create a predicted harvest date, and this is something that previously they're doing manually. So you couldn't actually do it without going out in the field. So this is a huge leap forward in detecting the bricks, measure the sugar content of the grapes or the Beaumais, as well as TA and pH. So quite exciting there.
Yes, David, I never could imagine that there'll be a work from home aspect to the harvesting piece of it, but now you're able to find a work from home hybrid way of working even in the harvesting. So that's amazing. That's great. So Bram, how about you? So any examples that you could share?
Yeah, I mean there's a bunch across the spectrum. Kind of again in David's area of interest, on the precision agriculture, folks are looking at how to leverage AI and robotic systems on the farm to not only do precision agriculture, but also to sequester carbon. It's like using the process of regenerative farming to not only produce more food more efficiently, but also to store carbon in the ground. So if you think about it, there's about 10 times more carbon stored in the ground than in the air. So it's a great place to keep it. Other spaces, folks again are looking at building more accurate environmental models and using those to do better, more focused short-term and long-term weather forecasts, which is a big deal, especially as we see climate change happening. Our ability to predict, or at least anticipate what's about to happen, will the more we can improve that, the better off we'll be. The excuse me. Again, other places, I'm actually working with a startup. They're working on a carbon neutral, carbon negative approach to building concrete, which is one of the biggest challenges in the kind of built environment space, because 1 ton of concrete is basically 1 ton of carbon.
I see.
And they're working on a technique to do this using actually waste material from fossil fuel plants like coal plants, et cetera. And even though we're economically we're hoping to phase out coal operated plants, there's still an enormous stockpile of waste material from these plants, and being able to take that material, turn it into a mechanism to sequester carbon would be enormously helpful. If you think about the built environment, I think the estimate is that we basically, globally, we add basically New York City every year. Wow. In terms of buildings. So you can imagine that's a lot of concrete, that's a lot of carbon. So, but given the variability in that waste material, having an AI solution, using AI to optimize that is necessary, because you can't just wing it. But as David said, it's the issue is, now that we have access to so much more data, that AI-based solutions are really the only way to process and use that data in any meaningful way. But in addition to all the satellites and stuff that Dave was talking about going up, and those numbers, while for stargazers it may be a little disconcerting, but there are other solutions, there are other approaches to getting high resolution data with companies like Near Space Labs who have, high resolution systems that go up on balloons. They go up temporarily, cover a, let's say a New York City size area, give you 10 centimeter resolution. So, we can, again, we are going to have more data than we can possibly manage. So
yeah, and that's why the I think AI comes into picture. So David, I think you have some examples in the soil carbon sequestration as well. So you want to share?
Yeah, for sure. And this is quite an exciting use of AI and data. So in this case, if you implement, if a farmer puts in regenerative agriculture, so basically the typical vineyard is a great starting point and great use to this, where you kind of see what looks like a clean vineyard. It has rows of vines, and then it has bare soil between it. If you actually plant a cover crop or put in compost or other areas in between where the vines are, it actually starts to build in soil organic carbon, which and actually build plant matter, and in the soil it actually will then sequester CO2 out of the atmosphere and store that carbon in the ground. So it's a simple way of actually sequestering carbon and taking carbon out of the atmosphere just using nature-based techniques. And to date, you can actually get credits for doing this, but to date it's been so expensive to actually prove the cost of testing and measurement that it's been somewhat prohibitive for people to kind of fund it with these carbon credits to do the practice changes. Where we've come along, which is very, very exciting, is we've taken millions and millions of soil samples, matched it to those satellite imagery, and actually worked out a way of understanding what the soil organic carbon is in the topsoil, so the first kind of 30 centimeters or so, and understanding and measuring that without actually having to go out there and manually measuring it. That measuring cost, someone has to drive out there with a truck, dig a core sample, send it away to a lab, drive it back, send it away to a lab, wait for results. We can actually measure that on a weekly basis, every 3 to 5 days, and we've actually been able to get 93 to 96% accuracy in lieu of a test. So their tests might be $50 a test, and they might have to do hundreds of them to really get those credits over time. And we can do that remotely, monitoring it. So it significantly makes it more cost effective for people to do it. So that's a huge leap forward using AI, the new data, the data sets of satellite imagery that's out there, to really enable people to put in these regenerative practices to sequester CO2 out of the atmosphere. So it's a great kind of mix of all those.
Hey, great. So actually there is a question from the audience. Future Earth. Okay. The question is, I don't know if it's relevant, but anyway, we'll read the question and see if we can address in the context of AI in the energy conservation. So the question is, the number of satellites launched have multiplied immensely. David, you made that point, with potential, while potential is positive in terms of ecosystem monitoring. Yes, given. But how can we also monitor space debris? Is this a concern? So this can be probably addressed if AI is trying to tackle space debris as a potential thing. So maybe Bram, have you seen anything in this space?
Nothing comes to mind. It is an issue, putting up SpaceX, or Elon's company is putting up thousands of small satellites, which, as I mentioned before, like astronomers are complaining about, because they do obscure the star field and for telescopes and stuff. So that's an issue. But we have systems to monitor the near Earth environment, and we just have to hope that folks are dealing with it. But these companies do have to be responsible and can't just think we can just do this just because we can. There's got to be some both private and public and international cooperation around managing the environment around the planet.
So yeah, I can add to that a little bit if it's helpful. There are, because we talk to a lot of satellite companies and have been be involved. We kind of consider ourselves a space tech company at first, for sure. We definitely play in that space. there are actually companies that are being launched and exist already that are focusing on cleaning up space debris. I think I'm trying to remember the name. I believe it's Astroscale, but I can come back to it afterwards.
Yeah.
Among others that are actually there to clean up space debris. And I know that people are also developing algorithms to detect when to pick up the piece of debris is coming, and then what it's, if it's dangerous, what it's I don't know if its path is going to be around the Earth, so that they can take maneuvers to kind of go around it. So I know there's companies in both those sectors that are having to be created because of these new pieces of technology and the amount of satellites that have been launched. So there are companies that are focusing specifically on this problem. So
yeah,
great. So an entrepreneur, when there's a problem, they will jump in, and so obviously they're looking at solutions. So that's great.
Yeah.
So, hey, another great question. So Nilushi, first the comment is that thanks, super interesting dialogue, guys. So you're making it very interesting. So Bram and David, so lots of excitement out there. The question here is about access to the data, right? There are many actors out there. So David, you made the point, the satellite imagery data is available, lots of data sets. And so both of you, we can start with you, Bram. So is there a concern about bad actors getting access to this data that's there? Are the discussions about managing the access to the data? So I mean, it can go both ways, right? So you want access to data as much as possible so we can come up with solutions. But at the same time, people using it for the wrong purpose is a global concern as well.
Yeah, I mean that bad actors are always a concern, especially in the AI space. There's a lot of fear out there about AGI, artificial general intelligence, and Skynet taking over and so on and so forth. But honestly, the biggest threat of AI today is not that; it's just people using it to do bad things. So that is, personally, that's my big concern.
Okay.
There's no real way to restrict the access to the data. I mean, if you're selling it, you can't always know what people's intent are, if they're willing to pay you for the data. I mean, and obviously some people can steal the data. But it's just, there's a lot of technology out there that people can use to do bad things. We just have to have the system, and the processes in place to deal with it.
Right. So, David, same question to you. So, I know you mentioned this access to data. Is it a pay to play? Are there any access restrictions? You have to qualify to get this data. So, can you talk a little bit about this access to the data, please?
Yeah. So a lot of our data has historically come from customers or publicly available data that has been out there. So obviously, customer data is treated with the respect it deserves. And we actually have some, especially down at the farmer level, they're also often concerned about, who's looking at my data, can I see it? And there's actually been some quite good principles in the agricultural industry that on data governance and data security, actually by the farmers, one in Australia called the National Farmers Federation. And there's kind of 3 levels, basically. The farmer explicitly gives you permission to use their data for anything and anyone. Another is to use their data in your models, and maybe at the regional or kind of the state or at level like generalized, but you don't share any specific data, specifically to their farm without the permission. And then lastly, that it can be used in a model, but it can't really be shared in any way. So those are, I think there's some good practices that are out there. Of course, if anyone, we follow that because we're trying to make, we think that it's 98% positive, the use of AI and the step in change technology that we're able to do. So what we're voluntarily adhering to that. But obviously, if there's a bad actor, there's people out there who will take someone's data and then sell it onwards. There's not much need to do. So, but I think it's important that people kind of follow those guidelines and do the right thing in that regard.
Yeah, actually, this has been a big issue in the financial industries, as you guys know, in the mortgage practices when they put the models together. So initially, I think it really led to bad results. As a result, the things that you're saying, David, like anonymizing data, making sure that things like race, sex, and all this are anonymized, actually not even discussed, not even considered in doing like a mortgage as an example. I think those practices are in place. Not only practices, I believe the regulations in place to do in some industries. So here you're talking about practices, so that it's more about people have to adhere to the practices. So that's great.
Yeah.
All right. Okay. So with that, so now let me switch gears a little bit into the investment space. Again, we don't want to go too deep into the investment space. And the investments into AI have skyrocketed, definitely in the last few years. And so, Braham, what is the case in the investments of AI? I mean, into AI, into energy conservation. So, is there a lot flowing in? Can you talk a little bit about that?
Yeah, I think it in many ways it mirrors the broader, ecosystem around AI. You see obviously a lot of money going into these foundational models like OpenAI and the big players, but you see a lot of money flowing, and I would say incorrectly flowing, into, oh, we can do this thing with AI. Let's build a solution on top of this, and your solution is in fact not differentiated at all, because anybody else can come along and build the exact same thing on the exact same foundational model. And unless you have proprietary data or a mechanism to build proprietary data,
Mm-hmm.
I don't see any longevity in these companies. The best outcomes for most of these companies will be acqui-hires. They'll get hired by some larger player that's like, oh, these are talented people, let's hire them. But it's the model, it's not your algorithmic approach that matters. And the model is a combination of your algorithm and the actual data that you have to generate a solution. But I think I think we see the spectrum in in the climate and environmental space for applications of AI, where people are like, oh, I can do this thing with AI. Okay, but you're you're not really doing anything all that special. You may be one of the early people doing it, but there's nothing about what you're doing that's really, gonna separate you out from anybody else, any other smart person that comes along and says, I know how to build a model.
Right.
But the folks, David's company is a perfect example. He's building up a hugely valuable proprietary resource that will, enable him to deliver real value to his customers. And that's what, as an investor, that's what we want to see. I'm a
Hey,
technical person and I can geek out on the AI stuff all day, but if that's all you come to me with, I'm not that interested.
so David, that is a huge, pat on the back for your company from an investor that you're meeting on the panel here. But so, David, question to you: as I don't know whether you're still raising or what space you're in. What has been your experience about the investments into this space? It's challenging, or where are you guys at?
Yeah, so us specifically, we're in our seed round. We just raised our seed round. It was eventually slightly oversubscribed, which is good. We actually have about we raised raising £1.7 million or $2.1 million. We have about £350,000 left. Anyone on the panel or otherwise wants to or on the call is interested, just there. But that said, I would say if you have a solid business case, and you have and when people look under the hood, you have good AI, and you're actually solving a meaningful business problem. I think any company is investable, if that makes sense. Obviously, there was we had a couple of stop starts in our seed round where when there was turbulence in the market early last year, we had some investors commit, and then they actually folded as investment funds. There's not much you can really do about that, but we kind of got across the line in the end. But it definitely was a challenging time, just the general environment. That said, I do think that the sectors that we are part of, which is space tech, which is sustainability in agriculture, and then also in AI, then people are very interested to invest in. Because we are in agriculture, I think the time horizon, the investor has to be aligned that the time horizon takes a little bit longer. Agriculture takes, like my experience, longer to adopt than other industries that I've been part of, but they are very, very loyal and great customers once you have them. So that's just my general experience. So I think you have to have that in mind. But if you have a great business and you want, this is more to the entrepreneurial side, and you really believe in what you're doing and you're there for the long term, there will always be people willing to invest to go along with you in that journey. So
Great. So, David, I just want to follow up on this thought into my next question. This is the last question before we go into the next section. So the question here is, there's always this discussion about hype versus reality, right? So, and then as Bram said, AI has gone through multiple phases, multiple winters, and now we're in this phase. It seems unstoppable. But again, right? So when it's really the peak of the hype, it almost seems unstoppable. But you guys have been able to make some, I would say, impact with actual solutions. So could you talk a little bit about how do you show the reality of your solutions of AI making a real impact into this one? Because you're either commercializing your solutions or you're selling. So can you talk a little bit about how are you navigating commercialization, actually making money, as opposed to continuing to invest into this space?
Yes. So we just a little bit of history on us. We started. We formed the company in 2018. We did a bunch of research in 20 and about 2020, 2021. We released a kind of first bit of the product. It's about 25% of what we complete vision in terms of our product offering, and then over that time we've got customers, but we've also kind of finished off our product vision. We're about 95%, 99% of what we thought we would be at least for the wine industry, and now we're looking at adjacent markets. There is some reality that people, AI is not only a new technology. It's often a new way of doing things. So a very simple example for us is people today on that maturity testing to determine, they go out there and they physically taste and they physically squeeze the berries at random to get an average across the block. You're now producing them something with AI that's a whole new way of doing things, saying, oh, you can actually see the maturity of your vineyard and you can determine when you're going to harvest that based off it. That's a big leap when they've been doing it that way for the last 20, 50, 100, 1,000 years in a way to do it. So a lot of it is around, first of all, giving them comfort that it works. So you really are going through that product adoption life cycle, starting with the innovators, getting proof points, etc. So in practice, what we've had to do and have done is actually done a lot of trials and paid pilots with people as a starting point to prove that it works. So whether that's on a region with a large company, or whether that's on a block in their vineyard on a smaller company, just to prove that it works. But one of the advantages we have is because we can go back to 2018, we can prove all our data is correct, and then it gives them value, and then they gives them comfort to move forward. So up to probably about a year ago, that was a typical sales cycle. Was okay, let's do a trial, let's prove that it works, and then move forward, which is very time consuming, but it gives them confidence that it moves forward. But that's some of the practicalities. Not only is it a new technology, it's actually a practice change, and I think that applies to banking, that applies to everything. So that's been some of the challenges in getting the technology out there and getting it adopted.
Yeah. So actually, thank you. So I wanted to understand how your journey has been, so that really helped. So Bram, from your perspective, you made the point very clear. Hey, it's data sets, and so that makes things real. And how? I mean, you definitely would appreciate of the Deep Planet's way of collecting proprietary data, making an impact, and those kinds of things. So to make these solutions real. Okay.
Yep.
So how do you go about looking at solutions or startups or companies, where there is the real stuff happening, as opposed to hype where things are being told to get money, or just hype.
Yep. So one thing we like to think about especially in the climate space is, one, a lot of times the climate benefits are hidden. It's like you're not selling climate benefits to your customer. And that's similar for the AI. You're not selling AI to your customer. I mean, if you're open AI, maybe you are, but for most, David is not saying buy our AI solution. He's like, buy our solution that helps you run your vineyard better. So he's, you have to, as an entrepreneur, you have to know where it is you actually add value. And the fact that AI is just an enabling technology for that. You're not selling an AI solution. A farmer doesn't care, right? If he could do it with a spreadsheet, he would.
Yeah.
Right. So one, if you're developing these solutions as a founder, you have to understand your customer really well. You have to know where you're delivering value and how you're delivering that value, right? You need to understand, and we like to see that you have that understanding and that you recognize that you're not selling an AI solution. The AI is just giving you operational efficiencies or an ability to analyze, massive amounts of data and then provide value to your end user. Without that, it's just a fun technology experiment. One of the challenges especially in the climate space, though, to think about, and David kind of alluded to some of this on the scale of his company, is that a lot of this application of AI is transforming legacy industries, and people have a way of doing stuff. So it's not just, this is a better, I can give you better information, but it's how disruptive is this to my process? Do I have to change how I do everything in order to fit this new approach in? Yes, it's better, but I have to change so many other things that it's cost prohibitive for me to even adopt your solution because I can't make it work. So that's the other part of understanding your customers. Understanding, just know how you're going to deliver value, but know where you fit in the process. Will people even use it? Yes, it gives me a 98% better, solution, but if I can't actually implement it, it's a problem.
Correct. So actually, so one last reminder to the audience about questions. So this is the final 10-15 minutes that you have. If you want to have any questions, go ahead and put them in the chat right now. So because very soon we'll be wrapping it up. So so David, I think you already alluded, and then Bram also mentioned about one of the challenges is, how do you work with industries, people who are used to working in a certain way, and then you're bringing in this new solution kind of thing. What other challenges have you or your company faced in your journey so far? And then through that, what insights can you offer to the audience?
So we are in, we're effectively helping monitor nature. And that's it's a great thing, but it also makes it harder because, as you know, there's so much variability in nature. There's so much uniqueness, whether it's different soil types or different ways of doing things. As an example, just as an example, there's over 100 grape varieties that we have to monitor, and they all have slightly, if we're trying to help people when they're ready to harvest or what the yield is or other things, there's so much variation in those that we have to account for. So when we went into it, we thought we would monitor all crops immediately, but then we realized we focused on one to really help us really get accurate on what we're able to do. So there's so much variation, and so that makes it somewhat challenging. But once you've done it, is also what Bram was talking about. It's actually protects us a little bit because we're 3 or 4 years ahead of anyone else, even if they put a team on it, because we've got this historical data and gone through all these challenges. In addition to that, is bad data. So if you allow bad data to get into your models, it can really make your life harder. Early on, we were actually able.
So, but David, how do you know bad data? Like, what is it? So I know of data that's formatted. Hey, it's not in a particular format. I know it's bad. But when the data is, you're getting it, but how do you separate a good data from bad data?
Well, as an example, we were able to predict yield very accurately early on, which was kind of somewhat of a holy grail for the wine industry. So we had to do it remotely with historical data and weather data and what we're picking up from the vineyard. So the first 3 years, we were getting accuracies around 95%, which is way better than kind of what they do manually, around 70, 80% in most cases.
Okay.
In the third year, we took in a huge swath of new data from an existing customer, and we were only getting 70% that year, and it didn't make any sense that our models would have regressed or got worse. And we checked the data that they gave us; it was right and everything. But it turned out that that data was from suppliers, and they were giving instead of giving the actual yields, they were just giving what contracted tons they provided. So unfortunately, in that perspective, it messed our model. So we had to take all that. It took us about a year to figure this out. So as you can see, like bad data can really set us back in that particular small little piece of the product that we do. And we had to change our approach on how we accept data and how we even do yield predictions at all. We do it more on an individual customer basis, and we validate that it's correct, and it's a 3-year project versus a kind of one-off service anymore. So that's an example of bad data that no one knew was bad until it actually.
That's what I was saying, right? So you don't know it's a bad data until after.
Well, that was very challenging. Yes, that was a learning experience for sure.
Yeah. So Bram, go ahead, please. I'm sure you have.
Yeah, I mean, I would just. Yeah, so kind of building on David's experience there. I gave a talk recently, and I opened with a question. I was like, what happens if you predict the wrong thing accurately? And that wrong prediction.
That's a good one.
Is going to depend on what variable you're using. What variables you're keying on in your data to build your model. The example I had given in my previous talk was around in the medical space, but using David's example, he what he found was he had a set of data that was actually one thing when he thought it was another, and his model was now predicting, not necessarily accurately because it did worse, but it was basically predicting the wrong thing. It wasn't actually predicting the thing he was trying to do. And I think one of the challenges especially in this space is that AI is such a specialized field that you have very technical people that come in and like, oh, I can apply AI to solve this problem over here. And what they end up doing is coming up with proxies, because that's what AI is doing. It's like, what are the proxies in the data that address this issue? And you find people, they often pick the wrong proxy. They think they're solving a particular problem.
Correct.
And they're making predictions, and their predictions are coming out accurately. But what they end up doing, and we do this across society in many different spaces, is we optimize for the wrong thing. If you think about it in terms of the social media space, right? We optimize for social engagement. We are not optimizing for teenage mental health. We're finding ways, in the people that are selling the ads are optimizing to get you to buy ads. They're not optimizing for your success at selling the product that you're advertising. So we optimize and predict the wrong things on a regular basis. From our perspective as investors with a focus on climate justice, that becomes a big issue for us, because your solution has to actually benefit the community that you're targeting. If you're optimizing for your profit and your sales, and primarily that, then that's going to be a problem because you're actually not helping the people on the other side of the data. And for us, our thesis is that, optimizing for the people on the other side of the data actually gives you a better market opportunity and opportunities for growth. But lots of people don't always see it that way.
No, not necessarily. So great points, guys. So with that, so we covered a lot of ground on one hand, and at the same time, we have barely scratched the surface of this topic. So David, so please, if you can take a couple of minutes to conclude your thoughts, please.
Yeah, for me, like you said, we're just scratching the surface, and I'm actually really excited about the future and what's possible. For us, in particular, the measurement of soil organic carbon remotely can actually help really drive effective regenerative agriculture, and I'm really excited about the impact of that measurement of scale on the implementation of regenerative farming, and therefore helping sequester CO2 out of the atmosphere. So for me, that's probably the most exciting thing that come out of our, we started this in vineyards, and we've added just as many people outside of vineyards to do this specific thing in the last 6 months as we've had in vineyards. And so we're very excited to see this technology get propagated and really make an impact, not only in environmental monitoring, but actually driving adapting to and reversing the effects of climate change. So that's the most exciting thing for me, where AI and data and this initial work in helping precision agriculture is really going to drive change in the climate. So that's the most exciting thing for me that AI has been able to enable.
That's excellent. So Bram, your concluding thoughts, please.
Just, AI has broad applicability across, many areas in the environmental space and outside of it. My concluding thought is solve a real problem, add real value to the end user, and you can build a successful company. And just know what problem you're solving and who you're solving it for.
Excellent. Gentlemen, that is very insightful discussion. So thank you very much for your comments. And again, audience, before you log off, take a couple of minutes to give your feedback. And please reach out to Bram or David if you have follow-up questions. They are prolific on LinkedIn. So go ahead. And then David, of course, is still looking for investors. So if you're into this area, so go ahead there. I mean, these guys are solving real, meaty problems out there. So I'm very excited for you guys. Take care.